Okay, so what we're going to do now is we're going to talk about how to solve problems of quadratics, problems involving quadratics. The process for problem solving with quadratics is no different to the problem solving process for previous algebraic problems we've had, just linear algebra problems. So let's quickly recap it. You would have seen this or something very similar to this in the past. I'm quite confident of that. So the first thing we need to do is read the question. Now I know that sounds obvious. What I'm saying here is you need to read the question carefully, making sure that you fully understand what's been asked and actually answer the question asked and don't answer something else that you think they're asking for, if that makes sense. So you've really got to be careful, read the question carefully, look for little things like different units of the question they might have. Just be really careful of the little traps that might be there for you. Step 2 is to draw a diagram if appropriate. If it's appropriate to draw a diagram, then you must draw one. It's not an option, you must draw one. If it's not appropriate, then you don't draw one. Secondly, or thirdly should I say, you need to assign a pronumeral, most commonly x, but you can use other letters if you want. Assign the pronumeral to what it is you're trying to discover. If it's asking for the length of the side of a triangle, then you assign x for that length, etc., etc. Then once you've assigned your pronumeral, you form the appropriate equation in order to solve the equation and find out what the pronumeral is. Step 5, and last but not least, you give your answer in words. Commonly forgotten in problem solving, if the question asks you for the length of something, you don't give a final answer x equals something. The question didn't say what is x, the question asked for a length. So your final answer would be the length of the triangle is. Okay, so you should be relatively familiar with this process. It's no different for quadratics. Now for an example, we're going to do question 20 as an example. So let's go through the steps I was just talking about. The first step is to carefully read the question. Okay, we can do that relatively easily. The length of a paddock is 2 metres more than its width, and the area is 48 metres squared. Find the length and the width. Okay, so we've read the question and we're pretty confident that we understand what's been asked for. Step 2, draw a diagram if it's appropriate. Is it appropriate here? Clearly it is. So let's draw a diagram. So we've got a paddock, and I guess the question isn't all that great in the respect that it doesn't say that it's a rectangular paddock, but I guess we have to assume from the information given that it's a rectangular paddock, although not really well explained in my opinion. So let's draw a diagram. We draw a rectangle. Apologies, it's not beautifully straight lines. Okay. If we go back to the question quickly just to get the information, we know that the length is 2 more than the width, and we need to find the length and the width. So going back to our diagram, we now need to assign our pronumerals. Now we don't want to use a different letter for the length and the width because it's going to make it much harder to solve. What we want to do is we want to write one of them in terms of the other using the same letter. So let's call, don't need an S there, let the width be x, or a letter of your choice. And we record that on our diagram. Now we know from the question that the length was 2 more than that. So we're going to call the length x plus 2. And by doing this, we are using the same letter for both of our parameters, which means it's going to be much, much easier to solve. Okay, we also knew from the question, if we buzz back really quickly, that the area was 48 metres squared. So therefore, if we times the length and the width, we'll get 48 metres squared. So we can form our equation now, which is step 5. X times x plus 2 equals 48. Okay, so we've formed our equation. Now we need to solve it. In this instance, based on what we know, the best thing to do is going to be expand the brackets, rearrange the terms, get 0 on the right hand side, and then solve the equation. So let's do that. If we expand the brackets, we get x squared plus 2x equals 48. If we now rearrange the equation to get 0 on the right-hand side, we would get x squared plus 2x minus 48 equals 0. Okay, so we're now ready to factorise and solve this equation. You could solve it using the quadratic formula if you want to do. You could jump straight for the formula, but if it's a relatively easy one to factorise, then I recommend that's what you do. So if we factorise this left-hand side, solve it, that's probably the best method in this case. So what we have to do, we have to use the sum and product method, because there aren't any highest common factors to take out. The x squared coefficient is 1, so we go for sum and product. We look for two numbers that times together to be minus 48 and add together to be plus 2. And the two numbers that do that are 8 and minus 6. Okay, so take a sec just to check that's the case. 8 times minus 6 is minus 8. Yep. 8 plus minus 6 is plus 2. Yep. So there are our factors. So x plus 8, x minus 6 equals 0. Okay, so we've got two possible results for x. X could be minus 8 or it could be 6. Now in this particular instance, when we're talking about length, one of those answers doesn't make sense. Minus 8 doesn't make sense. You can't have a length of minus 8. Okay, so whilst minus 8 is a valid answer for this particular equation, it's not a valid answer for the problem at hand. So we can just cancel that and say, well, minus 8 isn't the one we're looking for. So the one we are looking for is 6. So therefore, x equals 6, and x plus 2 would therefore be 8. So the dimensions of my rectangle are 6 by 8. And I'm not going to forget that the final answer should be in words. Okay, so the final part of the question is to write the answer in words. The width is 6 metres and the length 8 metres. The question is now complete.